Hello, everybody. So, the final video for today is going to be about how to build a system call. So this is not a user program. This is a program that runs in kernel. So programs run in user and kernel mode. So this is the bridge between the user and kernel mode. And the system call, the name of the system call is going to be non non number of system calls, non system calls. So this is the tester program for that system call. So this is going to work as follows. In the previous video, we created the user program called syscall. So in this example, I call it Roland. Let me show you what I'm expecting, how I expecting this program to work. So let me start XV6. So in the previous video, I create call syscall, and this just output the PID of the calling process. If I call in again, I run again the program, and this is a new program with PID 4. If I run it again, so I have been running this program 1, 2, 3, and I create a new system call. Let me call non times tester. This is the user program that called my new system call, and this guy is able to count the number of times that I call get PID. 1, 2, 3. That's why I get this 3. Perfect. So let's create this new system call from scratch. So the name of the system call is going to be non times. It's going to be non times get PID. This is the name, is going to be the name of the system call. So to create this system call, we will have to go for all the files of this table. These are the table in lab number 1. So the first place to visit is in folder include syscall.h. So we will have to go there. So let's go. So in the include folder, we will visit syscall.h. And there, I already did. I didn't have this line before. I just added. So you just type define sys and non times get PID. And this will be the number 23. In your case, could be the number 22. And then I save this thing. And every time that I do a modification, I'm trying to compile the kernel to see that everything is working well. So far, seems that this modification worked well. So let me get out of XV6 and let me continue following the table. So already modified this one. I have to go to kernel and modify sysprod. Here is when the place when I actually create the system call. So let me go there in kernel and sysprod.c. So here is interesting because what I want to do is to count the number of times that I'm calling get PID. So I just modified this thing, but this is the original function get PID that I'm calling. This is how it looks like. So I just figured it out. If I want to count the number of times that I'm calling this function, all what I have to do is to define a counter at the top equal to 0, and every time that I call get PID, just increase it. Counter plus plus. Good. And then I will have to create, this is just getting, increasing the value of counter every time that I call get PID, but then I have to create my actual system call, which is following the same format that the others, this one, in sys, and this is my system call, num times get PID, same format, and it's going to return the value of counter, right? Return counter. It's going to return the value of the global counter. And this is the system call, The rest of the elements of the rest of the elements of this table is just registering things. For instance, in user usys.s. Let me go there. In user, being usys.s. All what I did was to add a new system call here, syscall num times get PID. This thing wasn't there, but I added. And then I will have to go to the next file to visit, user.h in user. Move this thing, bin user.h. Same thing, I just register here my new system call, num times get PID, following the same format of the previous system call. And just continue doing this thing, and I will go to the next file, which is sysfunc in kernel. So I have to move to kernel. Go to sysfunc.h. Again, I register my system call here. And then I have something here. And then I will have to go to syscall.c in kernel also. And you will see that I do the same thing here. I follow the format, right, of the previous system call, this thing here. And if we follow the, and then we will have to create a tester. So I did the tester, which is a user program to call this system call. So I did that in the user folder. And I call it being syscall num times, I call it like that, num times tester. Basically, it's as any user program, but it's calling the system call num times is get PID. And then finally, I have to register this tester in the makefile.nk in user. So this is num times tester. Oh, sorry, I have to register it in makefile.nk. So it's here, I put it here. Oh. So finally, and the final thing is to see if everything works well. And I have been compiling all the time in every single step to avoid any problem. So make Kinonox. Perfect. And here I'm gonna call the program to call the process ID, which is, let's see, what was the name of that program? I called it before, call sys get PA. Okay, let me see. Clear. Here, user. Make file. The name of that one is called syscall. This is called syscall. What is called syscall? Is the program that called get PID that I created in the previous video called syscall. So then make emu nox call syscall, call syscall again 2 times, call syscall 3 times, call syscall 4 times, and our new tester program, which is num times get num times tester 4, because I was calling the get PID 1, 2, 3, and 4, and just create a new system call. Thank you.